Both these problems of the NEET belongs to current, electricity, and particularly Kirchhoff's second law. So, I will first quickly tell you how does we apply Kirchhoff's second law, and then we will solve these problems. First thing is Kirchhoff's second law, which is also called Kirchhoff voltage law, can be applied only for a closed loop, only for a closed loop. That is the first thing. Second thing is, when you are applying the Kirchhoff's voltage law, we shall consider either clockwise or anti-clockwise direction. We can choose any direction, that shall not be a problem. Next, in the direction that we have chosen, if we get negative plate of battery first, treat that EMF as positive and vice versa. In the direction that we have chosen, if we have resistor and the current is in the same direction we have chosen, if we have the resistor and current is in the same direction that we have chosen. Yeah, if we have a resistor and current is in the same direction that we have chosen, then treat that voltage drop across it as negative and vice versa. So, basing on that, basic things, let us try to understand what is the meaning of that. Look at this problem. Say for example, he has given current is passing like this. He mean to say that current will further pass like this and come back. So, first thing that we need to make sure is we have to check whether this is a closed loop or not. So, this is a closed loop. First condition is satisfied. Then we shall consider either a clockwise direction or an anti-clockwise direction. So, for the convenience, anything can be chosen. Let us choose a clockwise direction like this. You can choose any direction like this. So, we have to choose a direction, second is also satisfied. And look at the elements, like you are going this way. As you are going, first you get the positive plate of the battery and then negative plate of the battery in your path. Look at the direction, look at the rule. If you get negative plate of the battery first, EMF is positive. But while you are going like this, you got the positive plate of the battery first, and then further while you go, you got a negative plate. That means that EMF is negative. So, I have to say minus 2 volts. And look at the direction of current. You are going in this direction, and in this element current is going in the opposite direction. If the current is going in the same direction, potential drop is negative. If it is opposite direction, potential drop is positive, that is IR. So, current is I, resistance is 1. So, it is positive because it is going against the direction that we have considered. So, that is positive. So, plus IR, I into resistance is given as 1. Now, come to this place. You are going this way. While you are going, you got the positive plate of the battery first on your journey and then negative plate. So, that is also negative as per the rule, minus 4. Look at this element, you are going this way, but the current is going in the opposite direction. So, same direction means current positive, opposite negative, opposite direction means positive. Same direction means negative, opposite direction means positive. So, that is also positive, plus I, and that resistance is also equal to R. Come to this place, here current is going like this, but you are going like this in clockwise direction, that is also, see here, opposite. So, the potential drop is also positive. So, that is plus I into 4 equal to 0. That is the rule, that the algebraic sum of EMFs and potential drops in a closed circuit is 0. That is Kirchhoff's voltage law. What is that? The algebraic sum of EMFs and potential drops in a closed circuit is 0. So, I have just applied that rule. So, I want you to remind the rule once again. First, it can be applied only for a closed loop. Next, we shall consider either a clockwise or anti-clockwise direction. In the direction that we have chosen while we are going, if we get the negative plate of the battery first, treat that EMF as positive and vice versa. In the direction that we have chosen, if the current is passing in the same direction that we have chosen, treat the potential drop across that resistor as negative and vice versa. Then the algebraic sum of all potential differences and EMFs in a closed circuit is 0. That is Kirchhoff law. Once you understand that, this is very simple to solve. Minus 2 and minus 4 is minus 6. I plus I plus I, 4I, 6I equal to 0. So, 6I equal to 6, I equal to 1 ampere is the answer for the problem. Now, let us apply the same rule to this also, Now, if you have a look at the equation, there is nowhere I1 in the options. That means what? I need not worry about this loop. Wait a second. I need not worry about this loop, because you will get an equation in that loop, but that is not required in that loop, right. So, let us apply all the rules that we have learned here in this loop. B, C, D, E, B. This is the loop B, C, D, E, B. So, first thing you have to check is it a closed loop or not? It is definitely closed loop. Consider a direction. You can choose any direction. I am just choosing clockwise. There is no rule I shall choose clockwise, but I am just choosing like that. But be sure about one point, that if there are two loops in a problem, in the second loop also I shall consider clockwise. For one loop clockwise, for another loop anti-clockwise, we shall not take, then we will get a wrong answer. That is the only rule. Now, look at this. Here it is given that current is going this way and our direction is also the same. So, that is the rule. If we are going in the same direction that we have chosen, current is going in the same direction, treat that potential drop as negative. So, that is minus I2 R2. Come here, we are coming like this, we are going like this. So, you are going like this, you get positive plate of the battery first and then negative plate, then that is minus E2. If you get negative plate of the battery first, EMF is positive, vice versa. Then we are going like this. Here while you are going in our clockwise direction, we face negative plate of the battery first and then positive plate. That means that EMF is positive, plus E3. Now, come here. Here current is going like this, but we are going like this, against. So, potential drop if the current is passing in opposite direction is positive, same direction is negative, opposite direction is positive, that is plus I3 R1, because this resistance is R1, that closed loop is over, equal to 0. where I am writing the rule like the algebraic sum of EMFs in a closed circuit is 0. So, minus I2R2 minus E2, though here we are having minus I2R2, there is no minus I2, there is a plus E2, so that is wrong. Minus I2R2 plus E2 is also wrong. So, these two are wrong. So, you do not have directly this option. So, you just multiply with minus the entire equation, then what happens? I2R2 minus of minus becomes plus, plus E2 minus E3 minus I3R1 equal to 0. Look for this option if it is there, right. See that I2R2 plus E2 both are same, minus E3, here is minus E3, here is plus E3. So, this is wrong, minus I3R3 here is there. So, this option B is the right answer. That is how we have to solve the problem, right. So, while you are solving this problem, the most important thing is applying a proper sign convention of Kirchhoff's voltage law, which says that the algebraic sum of EMFs in a closed circuit is always 0, right. You can relook at it, resolve it until you get the sign convention fixed in your head properly. Thank you for watching.